Hey everyone, welcome back. Rachel, how are you doing today?
I'm doing fantastic, Michael. Really excited to be here.
So let's talk about testing policies. It's super important, right? To know what access people actually have.
Absolutely, and that's where the IAM Policy Simulator comes in.
Okay, the IAM Policy Simulator. What exactly is it for?
It lets you test and troubleshoot various IAM policies. Think identity-based, permissions boundaries, SCPs, even resource-based policy.
So like for S3 or SQS buckets.
Exactly, you can see what happens without actually making changes to your live environment.
Wait, it doesn't touch anything live.
Nope, it just simulates the request. The only thing it tells you is if the action would be allowed or denied.
That's huge. So no accidental deletions or anything.
Precisely, it's a safe sandbox for policy testing.
That's brilliant for troubleshooting.
Totally, it pinpoints exactly which statement is allowing or denying access.
So it sounds super useful for avoiding real-world mistakes. What are some common situations where you'd actually use this simulator?
Well, you can test policies on users, groups, or even roles.
Okay, so like, see what a specific user can or can't do.
Exactly. You can also test permission boundaries.
Oh, like those limits on maximum permissions.
Yep, and resource-based policies too, like for S3 buckets or SQS queues.
So can it show how SCPs, the service control policies, would affect things?
Yes, it simulates SCP impact if your account is in an organization.
That's huge. What if I'm just drafting a new policy and haven't attached it yet?
You can test unattached policies directly in the simulator. Just paste them in.
No way. And real-world stuff like an IP address condition.
Absolutely. You can provide context keys to simulate real-world conditions.
That's incredibly powerful for troubleshooting. So testing policies, that sounds great. But who actually gets to use this simulator?
Good question. You need specific IAM actions. It's all about permissions, of course.
For console users.
Exactly. If they're simulating policies for users, groups, or roles, they need permission to retrieve those policies first.
Okay, so like IAM get group policy or IAM gets user policy.
Spot on. And for SCPs, that's organizations describe policy, for example.
What about API users?
Different actions there. They'll need things like IAM simulate principal policy or IAM simulate custom policy for unattached policies.
So if Bob wants to simulate Alice's policy, Bob needs specific permission to Alice's RN.
Precisely. It's very granular. The simulator won't just let anyone peek at everything.
That makes sense for security. So that's the policy simulator. What about Access Analyzer? What's that all about?
Access Analyzer is super cool. It continuously monitors your policies for changes.
Continuously. So it's not a one-time check.
Nope, it's always on. This helps catch issues as policies are added or updated, identifying unintended access.
Unintended access. That sounds critical for security.
Absolutely. It really helps you proactively address resource policies that might violate security best practices.
So it's flagging things before they become a problem.
Exactly. It delivers detailed findings, telling you who has public or cross-account access to your AWS resources.
Public and cross-account access. Those are big ones.
They are, and it provides clear answers on that, which is essential for auditing and maintaining control.
So it shows you exactly where the vulnerabilities are.
Yes, through the IAM, Amazon S3, and AWS Security Hub consoles, plus APIs. You can even export reports.
That's super comprehensive. So how does Access Analyzer actually work its magic then?
You create an analyzer in a zone of trust. This is your AWS account or your entire organization if you're using AWS organizations.
A zone of trust. That sounds important.
It is. It defines the scope it analyzes. You can only have one per region per account.
Okay, so it sets the boundaries. What resources does it actually look at?
It supports a ton, like IAM roles, checking their trust policies.
And S3 buckets, right, for public access.
Exactly. S3 bucket policies, ACLs, access points, also KMS keys, Lambda functions, and SQS queues.
So it's not just IAM entities, but all these other critical resources too.
Right. It flags anything external or unintended access outside your zone of trust.
That's super helpful for making sure things aren't exposed accidentally. Okay, so we've set up our analyzer. Now, how do we actually get the right permissions to use it?
That's a great question. You need specific permissions, and AWS offers managed policies to make it easier.
Managed policies like pre-built ones.
Exactly. For full access to everything, you'd use IAM Access Analyzer FullAccess.
Full access to Access Analyzer.
Right. It gives you all the bells and whistles for configuration and use.
What if I just want to look?
Then you'd go for IAM Access Analyzer Read-Only-Access. That's perfect for just viewing findings.
So read-only is separate from full.
Yes, it keeps things least privilege. And you can also craft custom policies too.
Custom policies. What actions would those include?
You'd need Access Analyzer Star for all Access Analyzer actions and IAM Create Service Linked Role for setup.
O for the service-linked role.
Precisely. It's crucial for the service to operate within your account.
Okay, so we've talked about what we can do to test policies before they go live. But what about after? How do we know if permissions are actually being used?
That's where IAM Access History comes in. It helps you see what's actually been accessed.
Also, it shows what's been used or not used.
Exactly. It identifies unused permissions. This is crucial for refining policies.
To what though? Like just overall services.
Both. You get two types of last accessed information, service level and action level. It's super granular.
Wait, so I can see if someone used S3. And also what specific actions they took within S3.
For some, service access is broad. Action level is more detailed, specifically for management actions like creating or deleting things in S3.
That's powerful for least privilege.
Massively. You only grant what's truly needed.
So after understanding what last accessed information is, how do we actually see it?
Good question. You can view it in the AWS Management Console under the Access Advisor tab for an IAM resource.
Access Advisor, got it. So that's for users, groups, roles, policies, all of them.
Yes, exactly. Or for more programmatic access, you can use the AWS CLI or API.
Okay, so console, CLI, a PI, are there any catches? Like a tracking period or anything?
There are. Service activity is tracked for the last 400 days. Action level details started April 2020.
Whoa, 400 days is a long time. What about who can see these reports?
Only the principal who generates a report can view its details. It's tied to their credential.
So if I run a report, only I can see it. That makes sense for security.
Precisely. Also, IAM policies are included, but resource-based policies or SCPs aren't in these reports.
Okay, that's important to know. So it's mostly about direct IAM entity permissions.
Right. It gives you a clear picture of what your IAM users and roles are actually doing.
So using this last accessed information, can you give us a real-world example of how an administrator would actually put this into practice?
Absolutely. Think of Paulo, an admin at Example Corp. He gives his dev team power user permissions initially.
Power user, that's pretty broad, right?
Super broad. He waits 90 days, then checks the last access data.
Okay, so what did he find?
The team only used 5 services: CloudTrail, CloudWatch Logs, EC2, KMS, and S3.
Only 5, not bad.
Yeah. So Paulo then refined their policy to just those 5 services, plus the necessary IAM and organizations actions, much tighter.
That's smart. Least privilege in action.
Exactly. He started broad, then narrowed it down based on real usage.
So this data helps you stop over-provisioning permissions.
Precisely. It ensures users only have access to what they truly need.
So we've talked about what users actually do. How do we figure out what happened if something goes wrong, or if we need to audit something?
That's where AWS CloudTrail comes in. It's like a block box recorder for your AWS account.
A black box, so it records everything.
Pretty much. All API calls, all actions by IAM users or roles, console, CLI, API tools, everything.
Is it always on?
Yes, by default from the moment you create your account. You can even send these logs to an S3 bucket for continuous delivery.
That's super helpful. So we can use it to see who did what, when, and from where.
Exactly. It answers critical questions. Who took an action? When did it happen? From what IP address?
And if something failed because of permissions, like a denial.
It tracks that too. It's fantastic for troubleshooting those permission errors.
So CloudTrail records all this stuff. How do you actually read those logs?
Great question. Let's break down an example log file from CloudTrail to see what kind of gold nuggets it contains.
Gold nuggets, I'm listening.
First, we can identify who made the request. There's a user identity field. It tells you the IAM user, like Jane Doe in our example.
So you see the actual username right there.
Yep, along with their account ID and access key ID. Next, when and from where.
Like time and IP address.
Exactly. The event time shows the date and time, and user agent tells you the source. Was it the console, CLI?
That's super helpful. What about what happened?
That's the event name and request parameters. It shows the specific API call, like get user policy, and which policy was involved, even the policy.
Wow, so you get all the specifics. Who, what, when, where.
Every single time. It's incredibly detailed for troubleshooting.
So after all this talk about policies and logs, what about something to help us build better architecture in the first place?
Oh, absolutely. That's where the AWS Well-Architected Tool comes in.
The Well-Architected Tool, what does it do?
It's a self-service tool that helps customers review their AWS workloads. It's like having a solutions architect right there with you.
So it helps you, like, check your homework.
Yes, exactly. It evaluates your architecture against the 6 pillars of the well-architected framework.
6 pillars, what are those?
Operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability.
And it tells you where you can improve.
It identifies potential risks and gives you a prioritized improvement plan.
That sounds super helpful for making sure your cloud setup is solid.
It really is. You get consistent reviews and step-by-step guidance.
So how does this well-architected tool actually work then? Like, what's the process?
First, you define your workload.
Workload, is that like your application?
Exactly. It's all the resources and code making up your cloud app.
Okay, got it. So you define that, then what?
Then you answer questions across the 6 pillars.
The ones we just mentioned.
Yep, operational excellence, security, all of them. The tool evaluates your response.
And gives you a report.
It generates an improvement plan with prioritized issues.
So it tells you what to fix.
Right. Plus, you get reports for audits and a dashboard for an organizational overview.
A dashboard, so I can see all my workloads.
Yep, helps with continuous improvement. And get this, it's free.
No way, free.
You only pay for the AWS resources you consume. Pretty cool, huh?
Well, that's a lot of useful information.
Yeah, definitely.
Thanks, Rachel.
Thanks for having me.